Okay, so good morning. So we will continue our discussion on control charts. So last class we had some issues while calculating the upper control limit and lower control limit. So all these things I will clarify in this class, and then we will go to the management tools. First, let me say the 4 rules which we have seen in the last class. After plotting the control chart, we have 4 rules to find out whether the process is in control or out of control. So there are 4 rules. So the first rule is, if one point lies outside the 3 sigma region. So this is the 3 sigma region. So I'm going to explain once after the, I have one more PPT where I'll explain. This is the central line, average line, and then this is the upper control limit. Green color is upper control limit, and this is the lower control limit. And if all the points, if one point is lying outside the control limit, it can be above the upper control limit or below the lower control limit, then the process is out of control. So this is the first rule. If one point falls outside, so here one point is falling outside, so the process is out of control. And the second rule is, if 2 out of any 3 consecutive points, so 2 of any consecutive points, if they are lying in this band, that is between the 2 sigma and 3 sigma region, either it can be in the upper side or it can be in the lower side. If 2 of the any 3 successive points, they are lying in this zone, then the process is out of control. The third rule is, if 4 out of any 5 consecutive points, successive points, they are lying between 1 sigma and 2 sigma. 1 sigma and 2 sigma, if they are lying 4 consecutive, they have to be 4 successive points are lying between 1 sigma and 2 sigma, then the process is out of control. The final rule is, if 8 successive points lying either above the center line or below the center line, it has to be successive points. If they are lying, then the process is out of control. So these 4 rules, because interpretation is going to be involved. Because one mark I will give. Finally, I will tell whether the process is in control or out of control. And if it is out of control, you have to tell what is the assignable causes. And of course, in the examination, you cannot do what we have to do. We have to identify the assignable causes. And then once again, we have to plot the control plot. Now, I will take one example. Yesterday, we had some issues. So now what I'll do is, I will take another example. The same thing, but it is from this book. But the method what I told is not correct. Today, what I am teaching is going to be the correct method. And now this is the data. This is the data on depth of keyway. You know, in mechanical engineers, you know what is keyway. It is in millimeters. So the dimensions are something like that. So we are having subgroup number 1. Don't worry about this data, is unnecessary for our calculation, date and time. So it is 35 mm, 40 mm. So the depth, it is given like this. So we have data for 25 groups. Of course, everything they're not given. So just for you to understand, they're given like this. There are 25 subgroups. Each group data, we have data for 4 measurements, 35 mm, 40 mm, 32 mm. So, and anything statistics, I told you, there are 2 things, but in the examination, I will ask only one chart, either average chart I will ask or range chart. So only formulas are a bit different. Okay, I will explain this and I will give this PPT also, so that this control chart you will be familiar. So the next step is, you find out what is going to be the average X bar. So what they have done is 35 measurements. And the average they are getting 6.36. One second. So there is some problem. One minute. I think This is, if you add up, you are not getting 6.36. No, actually, if you take average, it is not 6.3. I think there is some mistake. Okay, just give me 1 minute. I will tell. Okay, I don't know. Actually, when you have to add them, and if you have to divide by 4, you have to get 6.36. I don't know. This I will clarify. But the basic procedure is like this. You add all the 4 of them, and x1, x2, x3, x4, you add divide by 4, and definitely it will not be 6.36. It has to be 6.36 actually. I don't know what is the problem. I don't know. Maybe this is even no, that 3.5 also it is not there. So actually, what you have to procedure is we have to add them divided by 4. You will get the average. Highest minus smallest, you will get the range. So that way we have to do. I don't know what is the problem. So I'll clarify. But the procedure is like this. Each subgroup, all the measurements you have to add divided by the number. Here it is 4. You have to divide. We have to get it. You have to get the average. Same way, range highest, lowest. You have to subtract, and you will get the range. The next step is the center lines. How to find out the center line? We have to find out x bar. So this x bar is nothing but sigma xi by g, where g is the number of subgroups. In this case, the number of subgroups is 25. Actually, complete data is not available. The subgroup number is 25. And when we are adding average, we are getting 160. So 160 by 25, 2.19 by 25. So the procedure, what you have to understand is, you add all of them divided by the number n. So in this case, n is 4. So add them divided by 4, you are going to get. But in this case, you are not getting, but that is the procedure. And then here you add every one of them, then divided by 25, you are going to get 160.25. Now, the center line, to get the center line, if it is X average chart or R chart, center line, how to get the center line, which is nothing but sigma xi. In this case, it is going to be 160 divided by 25 we are going to get. Here, in case of range chart, is 2.19 divided by 25. You will get the range bar. So that is going to be the center line. So average of the subgroup averages. X double bar chart, that is called. So average xi is the average of the subgroup. Then this is the number of subgroups, n, in this case 25. Same average of the subgroup for R, that is for range, what is the average? And for range of ith group, it is like this. And then plotting the control, yesterday we had some problem. Only thing is now I clarify what we have to do. So upper control limit, we have to find out x bar plus 3 sigma x. Lower control limit is x bar minus 3 sigma x. And then in case of range chart, upper control limit, which is r bar plus 3 sigma r, plus lower control limit, which is r bar minus 3 sigma r. Upper, now UCL is the upper control limit, LCL is the lower control limit. And this one, population standard deviation. So that is why the problem comes. So we have to find out sigma x, which is population standard deviation of the subgroup averages. And then sigma r, we have to find out the population standard deviation of the range. For both of them simultaneously I'm explaining. So the idea is, in this case, first we will take average alone. So for average control chart, the upper control limit is x bar plus 3 sigma x. And then for lower control chart, it is x bar minus 3 sigma x. These 3 things you must know. How to find out sigma x, I will explain you. So to find out upper control limit, it is simplified like this. So upper control limit, we can get like this, x bar plus a2, which is a constant. And then r bar, we are finding out from the data. So yeah, upper control limit is nothing but x bar plus a2 into r. So this a2, if it is open, if the CAT2 examination is open book examination, you have to bring this table. So this is available in the Westerfield textbook. You can take it if it is open. I'm not very sure because we don't know. Only 27 up to 26 we don't know. But only thing is it is going to be offline examination, that is there, but it can be either open or closed. CAT exam they told it is going to be closed exam. So if it is open book exam, you have to bring this appendix. It's available, table A, you have to bring it. If it is closed book examination, I will give this table. So these things. So these thing for average, we have to A2 or A3, we have to substitute in the formula. For range, you will have this one, B2, B3, B4 will come. So any constant from this table you have to take. Now, for upper control limit, if it is an average chart, X bar plus A2, we have to get from the table. R bar, we will be calculating. I will show the calculations in the next slide. Same way, lower control limit, X bar minus A2 into R. R is the range actually, average of the ranges. Bar means average. Upper control limit for the range chart, it is D4 into R bar. And then LC, lower control limit for R chart is D4 into. This is the table, which in case of it is mostly what I believe it is going to be a closed book examination. If that is the case, I will give this one. Then only you will be able to do this control chart problem. So now, how do you are getting these values? So X bar, I told you from here. Don't worry about this one. Actually, what we have to add divided by 4, you will get something around 35, but I don't know why it is a mistake. So you have to get the average of this subgroup. For first group, subgroup 1, you get the average, add them divided by 4. And here you are not getting. Same way you do like this. You add them, you add them, you will get the total for all the 25 subgroups. What is the average? You will get 160.24. Next is R. R is also very important in the formula. R means the highest value, lowest value. In the subgroup, what is the highest value, lowest value? You find the difference. That is going to be the range. And then you add all of them, divide it, you find out the average, which is coming 2.19. 2.19. And the next page is, so X bar we are finding, sigma X 160.25 divided by 25 is the subgroup. 25 subgroups are there, we are getting 6.41, the average for all the subgroups. And the same way, range for all the subgroups, 2.19 divided by 25, we are getting 0.0876. Okay. Then upper control limit for X chart, that is average chart. Then for R chart, I will tell. So X bar plus A2, this from the table we are getting 6.41 plus 0.729 into R. R is this value, 0.83. So we are getting 6.47. The same thing I am subtracting. I am getting 6.35. So central is 6.41, upper control limit is 6.47, and the lower control limit is 6.35. Same way for R chart, it is like this. Upper control limit is D4 into R. D4 we are getting from the table. I'm multiplying by R, which is here, because this is range chart. R, I'm getting 0.2, and here 0 into 0, we are getting 0. Very small number, that's why we are taken 0. So this is how you have to find out the upper control limit, because a constant is going to be there. So if it is closed book examination, I'll give the table. I'll give the table so that you can do the calculations. Maybe when you come to the campus, I think one class we will try to we will take a data from one of the textbooks I'm having. So when you are coming to campus now, maybe one class we will do that. We will do that, and maybe you can submit that as the assignment, digital assignment 2. You can submit as the assignment. So that way we'll do the practice, because we'll take a full problem from one exercise problem from the textbook. We will do it and you will understand. And finally, we will say whether it is out of control or in control, all these things. And now plotting the points, some points are lying outside, because 6.41 is the center line, 6.47 is the upper control line limit, 6.35 is the lower control limit. You see there are 3 points lying outside the control chart. This is the control chart for X bar chart. This is the X bar chart. So clearly the process is out of control. 6.65 is much more than the upper control limit. Even here also it is more than the upper control limit. Here it is lower than the lower control limit. 3 points are lying outside the 6 sigma region. So definitely the process is out of control. And all these things, 6.65 and these 3 data, you see, they are given some reasons. You see, 4th subgroup, new temporary operator. Here we are having 6.65, which is much more than the upper control limit. The reason is we have a new temporary operator. That is why we are getting data like this, and the average is above the upper control limit. So this way we have to give the assignable cause. We have to give the. So here in your case, you have to assume. So depth keyway, the keyway usually will be done in a milling machine. Since the dimensions are quite high, the depth is quite high. That means depth of cut is given more. That means it is a new temporary operator. That is the cause. So you just call him, and we have to instruct him to be careful. And the next thing is, here also we are having 6.42, which is very near the upper control limit. Upper control limit is 6.41. Here the reason is damaged oil line. That is the reason the depth is quite more. And here the depth is 6.51. 6.51. So in this case, we are having 6.5. Here it is bad material. Bad material. So this way now we have to give some. In your case, you make some assumptions. And you give why the points are lying outside the control limit. So I will share this PPT. Only thing is, you please learn when you come to the campus. I think one day what we will do, let it be digital assignment 2. So one day I'll give a problem. So there is one exercise problem in Westerfield, which we will take and we will try to work out. I will tell the procedure. You can work out in the class, so that the second assignment you do it in the class, and later you can scan and you can submit in the. So that we will do, so that in the CAT 2 examination you'll be comfortable when we are doing the problem. Now moving on, we will move to the next topic. So these are all statistical models. Now we will have some non-statistical tools or management tools are available. So previously we have seen the summon management tools. Like that, these are all new management tools. We have seen cause and effect diagram, histogram, Pareto analysis. So we have seen some 7 types. Here also we have some 7 types. So these are all non-statistical tools which are used for quality control. The first one is called the force field analysis. So here a group of people will be there, and then they will take the objective. So in this example, to stop smoking, what are the promoting forces? First we have to find. So when you want to stop smoking, what do you think will be the promoting forces, and what are the opposing forces or inhibiting forces? So this way now we have to identify. The objective is going to be like this. So we have taken an example where stop smoking is going to be the stop smoking is the objective. So first you know very well poor health. So that is a promoting force. So health will become poorer. Yeah, I think you might have interacted with some smokers. So you know very well their health will be spoiled. So that is a promoting force. It will help. It will promote to stop smoking. And then smelly clothing. I think definitely we know. So many times now we have seen. Then poor example. We are setting a poor example. Somebody is smoking now. Only a hero of a movie. If it is then only it is a good example. Otherwise, if you are smoking now, it is a bad example. But movie, the hero will smoke always. So that is poor example is going to be the thing. And then cigarette smoking cost is also involved. So these are all promoting forces to stop smoking. Impact on others. And then inhibiting forces, habit. And you talk to smokers, many smokers now, it is a bad habit. That is a problem. So once you start smoking, that is the reason. You should never smoke, because I am never smoker. Even though most of my college mates, they used to smoke. That habit, if you don't have that habit, it will not come. After some time, definitely you will not be interested. And then addiction, habit, and then addicted. So you know very well what is that addiction. And then these are all opposing forces. Taste. So you should ask the smoker whether the taste is there. So whenever stress, so that is the problem. Whenever there is a stress, whenever there is a stress, I will go and have a cup of coffee. So luckily in 4th floor, we have the Tamil canteen very near to my place. And now I think MTech students are there. All the canteens are available. The only thing is we are all waiting for you. 14th students, all students will be coming. So the entire campus is waiting for you. So here, this whenever there is a stress, you will try to go for smoking. And then advertisement. And then nowadays it has come down because there are some restrictions. Cigarette advertisement is not that way. Previously, not all. So much advertisement. Even the cigarette companies, they have sponsored World Cup also. But still advertisement is there. So this way, any industry, they will take a quality problem like this one objective. They will take objective. For example, the surface finish is not poor. So then, what are the promoting? what are the, if you want to improve the surface, what are the things, what are the opposing forces. So quality point of view, they will take one issue and then they will identify what are the promoting forces and then what are the inhibiting forces. So when you come to the campus now, one day you'll take why student, if students should, why students to study well, what we have to do. Objective to the student should study well. For that objective, you'll see, you'll find out what are the promoting forces and what are the opposing forces. So many times what we find, not even in the online. I don't know, because many parents, even yesterday I spoke to the parents, what they are telling, once they come to the campus, students will start studying. That's what they're telling. We will see. But in general, no, students are not studying. Students are not studying. So to make them study, that is the objective, is to make them study. What are the promoting forces? What are the inhibiting? So we will come to the class, we will see, and we will have some brainstorming, and we'll find out what are the promoting forces and inhibiting forces. And we have to, the idea is we have to eliminate the opposing forces and we have to strengthen the promoting forces. That way only we have to improve, we can improve the quality. So this concept, this tool is called force field analysis. And the next tool is called nominal group technique. So in this technique, for everyone, this technique provides for issue, idea, input from everyone. So all these tools, people will sit together and some brainstorming is, even the previous case also, brainstorming is. So brainstorming means many people will be sitting together, they will be called for a meeting, and then they will be asked for their opinion on the issue. We will take an issue, on that issue, they have to give which is more important. So this example is the team wants to decide which problem to work on. So we have a lot of problems. Many times the industry, many problems will be there. Which problem is most important? So maybe some 15 people are there. There are some 15 problems, and everyone you ask them to take a piece of paper. So that's what brainstorming technique they will do like this. Everyone, you write on a piece of paper the problem they think is most important. And then the papers are collected. For example, 15 people are there. So they're taken. So all of them, they will give 4 or 5 problems. The paper are collected and all the problems are listed on a flip chart. And then each member of the team uses another piece of paper. Next, once again, rank the problems. So once you have 15 people, for example, each of them, they are giving some four issues, 4 problems they are giving each one of them. Of course, there will be some overlap. So 4 into 15, 60 will not be there. So there may be some 30 or 20 problems, because some overlap will be there. Usually, definitely overlap will be there. So assume there are some 20 problems. Next, you write down all the 20 problems in a piece of paper and ask them to rank them, which is most important, which is least important. Give them points. So most important, you give 1. The least important, you give 20. So all the 15 people will do that. And then the rankings are given a numerical value starting from 1, least important, and continuing with most important. So points for each problem are totaled, and then the item with the highest number points of is considered to be the most important. So if you, here they are telling the ranking numerical starting 1 for the least. Okay, I told the other way. So 1 is for the least. 20 will be the most important problem. So more number of points, that point will be taken as the most important problem. Then they will be. So this is called nominal group technique. The third one is called affinity diagram. So this is very much similar to the cause and effect diagram. So you have some issues, scrambled ideas. So this is what are the issues involved in missing ship dates. So if we are not transportation, we are not able to ship properly. So there is delivery we are not able to do on the proper date. So not enough, because trucks will be normally material will be transported through trucks. Enough trucks are not available. So there are always resource, there is a problem. You will have more orders because that cost is involved. You cannot have n number of trucks. You will have only based on the truck. So whenever there is any shipping issue means trucks will be there, not enough trucks, no place for returns, computer crashes, the person is not trained properly, overcrowded dock. So dock, this is actually harbor. The crowd is overcrowded means you cannot do the shipping. Teams not used, inexperienced supervisors, engineering changes, shipping turnover, error on billing of learning. So these are some of the issues. So scrambled, what they found out is, so here also brainstorming we are doing. So the issue is why shipping dates are missing. We are not able to ship the products in the correct delivery schedule. We are not able to keep up. So there are some scrambled ideas. So this affinity diagram, you try to, so people, you see insufficient training, teams not used, inexperienced supervisors, shipping turnover. So these are all people are involved. So that's what we are training in the cause and effect diagram. People, method, I told 5 M's, men, method, materials, measurement, like that, no, same. So here, if you take these 4 ideas, insufficient training, teams not used, inexperienced supervisor, so they are concerned with people. So you group them together. So this is ordered area. So this is because of people. People are not trained, teams are not used properly. There is a turnover in shipping, inexperienced supervisors. And then facilities, overcrowded. Dock means harbor. Harbor, the place where ships are being that is being overcrowded. So this is facility. No place for return, not enough trucks. So these are all our resources. So facilities, there is a problem here. That is why shipping dates are missed. Then system. Engineering changes, computer crash, errors on bill of lading, all these things. So this way, so this is called affinity diagram. So first you try to get all the ideas, it will be scrambled, and then you group them together. So here we are grouping them into 3 groups. Facility as one group, people as the second group, and system as the third group. So with this, I will stop for this class. And we will meet on Monday. We will meet on Monday. So some students, they made a request that assignment today, tomorrow is the last date I gave. So I'm extending it by 1 week. So since you are all coming from your hometown, and many students will be busy, and mostly they will be traveling today, tomorrow, and the day after tomorrow, they will be traveling. So what I'm suggesting is you can take one more week. I think 13th, Sunday 13th night 12 o'clock I will give. I will change in Moodle. So the first digital assignment 1, you have to submit before 13th. So 13th, very well you will come to the campus. Very well, I think 7th you are supposed to come to the campus. So 1 week time is there. So you please complete the digital assignment 1, and you have to submit on or before 13th. That is next Sunday, not this Sunday. Next Sunday, 12 o'clock night I will give. So you please submit the digital assignment 1. Digital assignment 2, what we will do, we'll do it in the class. Because there is some problem in control chart. So if at all something is there, I will clarify so that CAT exam it becomes easier. So when you come to the campus, the digital assignment 2, there is one hospital problem and data is available in the textbook. So that I will give. And I will just explain how to do all the things. You can do it, and then you can scan and you can upload in the Moodle. That is going to be DA2. So that is when you come to the campus. Maybe on 14th or maybe 16th. 14th, I don't know, some students will not be coming. So on 16th, we will do that control chart. We will do. So with this, I will stop for this class.